Okay, so let's continue our lection. So again, do you hear me and do you see my screen? Okay, then let's go back to class cat and class zoo. So I will show you one more interesting thing about functions that we can use inside classes. So previously we have called all functions, for example, defined for class cat, from outside. So we have called this catch mouse, eat, sleep, and so on. But now let's define some functions that will call functions of this class from inside. So let's define function void I don't know, perform action that, for example, takes nothing as arguments. And this function, so what probably cat will do, eat or sleep. So let's create a function that asks cat to sleep or to eat just by some random in some random manner. So how can we create call an action by some random result? So to call some function with, for example, 50% probability. So here we can do it new. So do you remember this random class? New random next int, for example, 2. So if we have this bound equal to 2, this means that so we can get here inside R, we can get numbers 0 or 1. So if I'm checking this R for 0, I will probably get some so code inside this block will be executed with 50% probability, and also here in else also. So this one with 50% probability can be 0 or 1, because next int with bound 2 will give us only 0 or 1. So this 2 is not included. And now let's call, so with 50% probability, let's sleep. For example, 1 hour and 30 minutes, or eat. For example, if I'm lucky today, if I asked my cat to play when he was sleeping, probably he will eat my hand. So please rewrite this code and let after let's look deeper in details what's happening. Okay, if it is done, let's go to the end of class zoo, so till the end of function main, and ask our cat prince to perform action. So when it is done, uh, let's look what is happening here. So here on this line, we are generating some random number that can be 0 or 1. So if it is 0, we are asking our cat to sleep, else asking to eat. But important moment here, when we call functions of an object from outside, we always asking a particular object to perform this function. For example, here we had a dog and we asked this dog to catch a cat. So if I'm just printing the function name, then Java compiler would not understand who should perform this function. Maybe this dog, maybe another dog, maybe we have some cat catcher class that have a function with the same name, but it's anyhow related to dog. So when we're calling function from outside, we are doing this by calling function via dot operator from some object, like we have done this all the time before. Here, when we inside this perform action, it is already happening inside some particular object. And here we can call these inner functions, for example, sleep or eat, without without this object and dot operator. So from the inside we can call, so the only way to call other functions just by calling them by name. So still we need to give some parameters, but we are doing without using this object name and dot operator. So just calling them by name. So let's debug this. And okay, so here we have generated random number from 0 to 1. So actually we got 0 here. Now we are comparing. If it is 0, we are calling inner function sleep. So I am going here inside, doing step into, and here's my function executed, sleep. So it is executed. I am going back to this function. So here we can call these functions from functions and so on. So this is called call stack. So usually we are creating objects, calling functions. Inside these functions, we're creating some another objects or calling another functions, and so on. We are going deeper and deeper until the last function completes. We are getting back to call a function and then going back. So this is how we performed executed this function with calling. Here we have called other inner functions from inside. So we actually can call them also from outside. We have already done this before. So we have asked already this cat to sleep and to eat, but we can also do it from the inside if it's necessary. So today I'm lucky. Random says that my cat just sleeps and do not eat my hand. maybe you have got a little bit different results from mine. So it is now clear how to call this class functions from inside. So basically just like from outside, but without object name and dot operator. So so just writing function name and parameters if necessary. Is anyone present here? I didn't get any feedback, so uh, let me repeat question. Is this clear with this function calling from inside? Okay, thanks. Okay, if it's clear, now let's go to next practical assignment. Okay, if your hand was eaten. Okay, here inside our frame homeworks file, we have one task that it is quite hard, but it is really good for understanding our next topic about Java collections. So it would be great to really implement this. So imagine a situation we have some application that works like a to-do manager. So we are opening it, writing some tasks for today, so entering some text, pressing enter, and it is now recorded into some collection of tasks for today. When we have done some task, we need to remove it from collection. So, okay, it is done now. Or we need to put some task between another task. For example, we are writing them in some sequence. So from morning I should do this. After dinner I need to have a nap. After then I need to have a supper and so on and so on. So just put some task between another tasks. And the only way how to store some tasks like this, we have only array of strings. But the problem with arrays that it is limited by size, and we can give it size only once, and at when we were declaring this. So when if we are doing such to-do manager, we need to create an array, but we do not know what size to give for this. And because we can, for today, for example, we are assuming that we will not have more than 10 tasks for a day, but actually we may be too productive for today and write, for example, 12 tasks. But now this will not fit into this array. Using array size some bigger than adequate that will be fit for every situation is not a really good uh, example of memory management. So we're creating array of I don't know million elements, but we will actually use only 5 of them. So that's not really great. So the solution is to create some wrapper around array that will works like a list. So we can create an object of this class and add some elements to this list, and it will grow out or shrink automatically. So how much elements we put inside this list, we will get this this collection will remain with this size. If we have entered 3 elements inside, it will show us that size of this collection is already 3. And then we can remove some element from this collection. We can add it between by index, for example. But how can we technically achieve this? So imagine that we create such class that will hold that will hold some array inner. So this inner array will not be anyhow exposed to outer world. So this will be actually some inner state, really inner and really private. So for our example, we will use integers to store inside. So when we create instance of this class, we will have just empty array of one element. So nothing inside. One element array and nothing inside. When we ask to put something inside, okay, we will put something inside. And now our array is full. Now, when somebody asks us to put extra element inside this, what we are going to do? We will create a new array with double size. Copy the old element and put a new one. Next, when somebody asks us to put some more extra elements inside, we will create new double size array, copy old elements and put a new one. If someone asks us to put one more element, not a problem. We have an empty slot inside, and we can put this one more element. If somebody asks us to do it one more time, not a problem. We can still create a new array of double size, copy old elements, and put a new one. So that's how should it work. We have a class that privately holds some array, and this array, because we cannot change the size of array and put some elements or remove from it, we will create a new array when the old one is full. Copy new elements, copy old elements, put new elements after all old elements are copied, and change this reference. So old array is deleted and new one is held. So just like we have done with this matrix class. So when we have created a new array, have done something and then changed this reference of so this inner state is now equal to new array. Exactly the same thing here. So for now, is it theoretically clear what we are going to do? Okay, so you have a time to perform this task. Okay, so that's a joke. Now, so let's start together, and then you will continue on your own, and this will most probably become your homework. So here inside OP package, let's create one more package. No, so okay, without a package, just let's create this class called awesome list. So this class will be without main function. And one more class behind called okay, list launcher. This one will be with main function, and here we will create a new awesome list instance. So awesome list is just empty class for now, and this list launcher just creates new instance of this awesome list. And tell me when it is done. Okay, so what I'm going so how we gonna use this awesome list class. So once we got some new data, we will call add function and enter some number some integers inside. And so we can do this operation as much as we want, and this inner state of awesome list will grow together with adding new elements. After we can call some remove elements by index, or put some value inside. So we will mostly call add function from outside. So now let's define the inner state. So as we have agreed before, we will hold this state as an array. So this will be one dimension integer array. Let's call this okay, just R. And the next important moment here, we can have during some time, we will have this inner array not really, so not filled till the end. So we will all the time, so when our old array will be fully filled with numbers, we will create array twice size. So our new array will be twice bigger than previous. And when we'll copy old results and add new, so we will have some slots empty. But technically, they are not empty. They are full with zeros. So if we define integer array, all the inner values are zeros by default. But if we will then try to print this array, it will show this array fully, so it will show us these zeros. So this can be sometimes legal data, but so we need to mark these slots as not used for now. And how can we do it? We can have some extra variable that shows us index of next element to add. So here we will have, so I don't know how to put here how to put here some arrow. Okay, like this. So we will have extra variable that that will shows us a current uh, size of our collection. So technically our array will be this. Here we have filled with values that have user entered, and these are empty slots. Here we will have variables that shows us this division between used part of array and unused part of array. So let's define here an extra int variable that is called let's call it index. Here we can add some default values. So from a start, let's create this inner array of size 1, and let's define this index with size 0, with value 0. And after you rewrite, please tell me, and we will go further. Okay, so for this class, actually we do not need a constructor because so we do not have any, let's say, initial values. So this one we can define that they always be the same. So in this class we do not need constructor. So now let's define this function add. So this will be void function because we don't. So adding is just like putting, I don't know, apples inside a box. So you put it and you do not expect nothing back. So here this add function is a void, and it has a parameter called value. So it will be a value that we need to store inside our array. So here it is definition of this function. And now after we have defined, we can call this function with some values. For example, with 5. So please rewrite this definition and okay, let's create some more calls here. Okay, I hope. Okay, let's have them equal to what we have here in this example. Okay, here we have 5 calls to add some new values. Okay, and so here inside this add function. So technically, this will be in a happy path will be equal to this. We are adding value inside our array by index. So here we are sending a value. And now, after assigning, we are incrementing our index. So in this case, so when here comes a new value, we will put value inside the next array slot. So this is happy path. But what is the problem here? Our array is limited by size. And if we will try to, if this index goes outside our array size, so we will get problems. We will get exception here. So what we need to check? We need to check current size of array and this index. So here, if index is less than array length -1, so only in that case we can add values to array. So -1 here, it is here it is because for example, we have array with size 6. So it has 6 slots inside. So index of the last element will be 5. So so if so we can add a new value in the last index only when this index is less than 5. So this so so let me think about it. Maybe I'm not right here. Okay, let's try just length here. Okay, so we can add a new value inside our array only when this increasing index is less than length. So it will if it will become equal to length or bigger than length, we will have problems because newly inserted value will go outside of array and we will get exception. So please rewrite this part together with else. And then we will cover case when we need to grow our array. Okay, here inside else block, we should cover case when our array is full, for example here, and we need to create a new one and copy old values here and put a new element here. So how we will do it? Okay, let's create a new int and let's create it double size of previous. Let's call this new array. And so please write me how, so what we have to write here inside this length declaration. So we need to create an array twice bigger than previous. So how this will look like here? Yes, exactly. So we're taking previous array length and multiplying this by 2. Very good. So what we need to do now, we need to copy contents of old array inside this new. So copying, so you might find in the internet way of optimized way to do it, but for now let's just perform the section with ways we already know how to do it. So here I need to copy values from old array into new array. So that's how I'm doing this. So I'm here have a for loop that you already perfectly know till the original array length, and here I just put value inside new array by same index from previous array. So please rewrite this part, and then we will think about how to add new value. Okay, let's think now. So how we will add a new value to this array? So actually we have already written this. So we are adding new value to array by this in. Sorry. What we have forgot to perform here. So now array is new array. So we have created a new array and overwritten the old one. So yes, actually forgot to do it. So now we have already written what to do if we have place inside array. So so we can copy paste this code, or any other idea how can we do it without copy pasting. Yes, great. Uh, so I have shown you recently how about how to call inner functions. So actually we can even call the same function. So here comes the value, but we cannot just put it simply in array because the old one is full. Here we're creating new array, copying values to from old to new, and now we can call the same function. So this execution logic will goes here, and now so we have already our new array, and now we will go here, just put elements inside array, increment this index, and we will go outside this function, and we will return back here. So this is called recursive function. So function that is calling itself, it is called recursive. So in idea, you will have this extra sign here. So if you put cursor over, you will have this hint that it is recursive call. So usually you should be very careful with such calls, because such calls sometimes may become infinite, and your application uh, will even not throw exceptions. It will just freeze and become useless. So in such case, when you call the same function multiple times, this can this can throw also exceptions called stack overflow, when stack of this call functions will become too big, or it can freeze. So please be very careful with such things. Now, okay, if you have rewritten these two lines on 17 and 18, now let's try to debug what is happening here. So now we will try to put sequentially 5 numbers. Now let's look what is happening here step by step. Okay, our first here we have just recently created a new awesome list, and this has index 0, so we are ready to insert element on index 0, so first element, and we have an array of size 1, so only one free slot with value 0, so it's just a default value for integer array. Okay, now first we're checking, do we have a free slot in our array? Yes, we have, because 0 is less than 1. So we are adding value to our array. Now you see here we have this value 5 just given inside value. So here is a hint, value 5 on index 0. So here's index, here's the value. And well, great now. So we are adjusting this index because to show on the next free slot inside array, and getting back. So now second call with value 3, and here we have problems because our array is from one free slot is already full, and we need to grow this array. So we are going to else, because this one is not true. Okay, we're creating a new array of size 2. Now this is array of size 2 and 2 empty slots inside. Okay, now we are copying contents from previous array. So here is the previous, and now we are getting value from previous array by the same index and putting it here with the same index. So here it is E. Okay, done here. And now we have this new array. So please compare them. Old one and new one. So they are same, except this new one is twice bigger, and it has values from previous array and some extra free slots. But they both has old values. Now we are forgetting, we are overriding this previous array. So now it is useless, and so old one became useless and will be gathered by garbage collector and destroyed. But now this reference points to our new array. So we have overridden the old. And now we have array with free slot. So now we are going to call the same function once again. We are doing this. And so where we got here on the first line of function. Now this first condition give us true because we have free slots in our array. So we are executing this logic of putting new element in array. Once this is done, everything that was inside if block is executed, else block is not executed, and we are getting here to the end of function. Now, next element. Now we are putting next element 2. For now, our array is now full again. So we had 2 elements and inner array is of length 2. So again, we need to grow array, creating new, copy old values, and let's look on this old array and new. So new has values of previous, this 5 and 3, and here 2 additional free slots. Now we have overridden this old array with new and calling add once again. So now we have free slots, putting new element, increasing index, and going outside. Okay, let's put a new. So how our array looks now. So 5, 3, 2, and 1 free slot here. Okay, now we have this free slot and just putting element inside and going outside because we do not have to grow currently. Now again we have to add new element, going inside, and again the same situation. We have our inner array full, so we do not have free slots. Again, we need to grow, create new array, copy contents of old one, and let's look on them once again. So new array of size 8 contains the values from everything previous. So here it is 5, 3 to 7, 3 to 7, and 4 free slots. Overriding the old array. So now we have the old values and 4 free slots. Calling add once again and just simply putting a new element to array. Now let's look on this array. So now it consists of some numbers that were added here and 3 extra slots. So technically they are it is one array just with 3 zeros here. So if we are going to print all this array till its length, so we will get these 3 zeros that are not what we have added here. So we have added only these numbers. We did not enter these 3 zeros. So here it's why we need this index variable. So this index shows us the real size of our collection. So not really. This shows us not real size, but okay, visual size. So this index points us at the same time to a new to a first free slot inside array. So 5 here, index 5. And this divides this inner array on used part, so this used part, and not used part. Okay, is it now clear how this add function works together with this inner array, and why do we need this extra pointer that shows us a first free slot in the inner array? Okay, if it is clear, now let's create some function that simply prints this list contents. So public void print self, and let's just print contents of this collection. So system out print line, array element, and space. So do you see an error here? What's the problem with this for loop? Yes, exactly. This will print also some these free slots that we still not used, but technically they are just zeros. So we have to change this r length to this index, and then it will works. So now let's ask our awesome list to print self. Sorry. Wow, looks like it works. So it prints only the numbers that we have added. So it doesn't print these extra zeros that technically are here inside this array, but with this limit we do not print them. So now please rewrite this function print self and its call inside list launcher. Okay, if it is done, let's get back here. And you see here are a lot of extra tasks, extra functions that needs to be implemented. For example, get returns stored value by index. So if I want get some element, first element, I'm writing here awesome list dot get 0. So here I'll expect some element by index 0. So this is function that needs to be implemented. But you will need to check. So you will need to check is this value inside array or not. If it is not inside, then you will need to throw an exception. So how it is done? So this is described here. Okay, so here inside matrix 3 homework, here's how to throw an exception in case this given argument is illegal. So here's just a little bit wrong text. So I'll show you example how to do it. So if some condition is met, then you can copy paste this code from previous homework with matrix. And here, legal index, for example. So you will need to copy paste this code in case someone is asked to get an element that is not inside array bounds. So okay, let me give a comment here in case get by inadequate index. For example, you can use the same when somebody asks you to remove element by index that is not present really in our array. So add and print self we have already implemented. We do not need to change them. So the basic functions are get, remove. Okay, at all that's maybe complicated. Another so size, that's really easy and nice to implement. Add by element and index. So it's about inserting. So if somebody now wants to add element here after 2 and before 7, so what we need to do, we need to take these elements here and put one more here. So and then put this still put this pointer to the next free slot. And again, in all these cases, in case when you are inserting objects, you still need to know about the real size and how much it is filled or not. So here it is. So equals and add all this. These are quite complicated. So put them just on a desert. So it is now more or less clear how what we need to implement. So no, you do not need user input. So just just test these operations here. So we have added 5 elements. Now you can you implement get function. Just call get functions. Just call get function with some real index so that our application would not be stopped. Then add one more. Implement remove. Try to remove some. Print it after. One more comment about this remove function. Mm, so if user removes, for example, this 2, what we need to do? We need to remove this element and then copy this the rest of elements that we have here. So we have to shift them by one position on the left. So like this. So this array will still, so we do not need to shrink this array, but we have to remove this element by shifting all the rest elements from the rest part of our collection to the left on one element. So that's how remove should be implemented. So any more questions about this? So responding to the latest question, no, you do not need any user input. So you can test your implementation just by some hard-coded values from this list launcher. So I have just explained how we should implement remove function. Okay, if no more questions, so implement just as much as you can. So get and remove functions that's and size functions that's a must-have. Add all no add by element and indexes that's nice to have. And these two add all and equals are let's say mm, these two are extras. So if no more questions, then this the rest part will become your homework. I will commit all this start in a GitHub soon, and so I wish you a nice evening. Luck with this homework. And by then, so today we will finish just some minutes earlier. So Have a nice evening and goodbye.